Hello everyone, I'm Dr. Alex Kent from Geography, and today we're going to be learning about the shape of the Earth and why map projections are important. Now, the first thing to notice about the shape of the Earth is that it's not actually a sphere, but it's what we call an oblate spheroid. So it bulges slightly outwards at the equator and it is slightly flatter at the poles. Cartographers also have to bear in mind that because it's a 3D object, we need to transform the coordinates of the 3D object onto a 2D flat surface to create a flat map. And when you do that, there's always going to be some sort of distortion. You can't preserve, for example, angles, distances and area all at the same time. So one of those properties at least is going to have to suffer. And the only way that you can actually preserve all three of those properties, angles, distances and area, is if you use a globe. Now, cartographers use mathematics in order to transform the Earth onto a 2D plane, such as a map. And one of the famous projections for doing this is the Makita projection that Makita devised in 1569. The idea here was that his projection preserved bearings or angles, which meant that mariners particularly could draw a line on his map and then use that angle at sea to get from one port to another. However, although Makita's projection preserves angles or bearings, it doesn't preserve distances or area. In fact, area towards the poles is increasingly distorted. So if you were to compare, say, Alaska with Brazil, on a Makita's projection they look roughly the same size, when actually Brazil is over 5 times the size of Alaska. So Makita's projection isn't that useful if you want to map, say, population density around the world, because you really need to use an equal area projection for that. In other words, where area is preserved and not perhaps distances or angles. But Makita's projection was particularly useful if you wanted to show off the size of your empire around the world, particularly if a lot of that empire was located towards the poles, for example, in countries like Canada. And so Makita's projection came to be used for all sorts of types of map without really thinking about its inherent distortions. And it wasn't really until the 1970s, specifically 1973, when Arno Peters decided to reclaim a projection that had existed in the 19th century by James Gall that had preserved area using therefore an equal area map, and by calling this the Peters projection he decided to throw the spotlight back onto the middle areas of the globe, particularly developing countries that were located around the equator. And this really aimed to redress the balance between the sizes, of course, of the different areas around the globe. So we have to be aware of the different distortions that are inherent to map projections and decide which is best according to the data we are trying to map. For this exercise though, what you're going to be doing is creating your own map projection by using a Satsuma, which is quite handy because it's in the shape of an oblate spheroid, just like the Earth, although a little bit exaggerated. You'll need a pen, a biro or ballpoint pen will do. I'm going to be using a permanent marker to do this with a fine point. And the first thing you're going to be doing is drawing the Earth on your Satsuma. So what you might want to do is hold the Satsuma like this with your thumb and finger at the top and very gently draw around the Satsuma, trying to notice the key characteristics of the main continents as you go around. Don't worry about drawing 16,000 islands of Indonesia or anything like that. Just keep to the very general shapes of the continents as you go around. And I'm going to put the map up next, so what you might want to do is pause it at that point so that you've got a reference in front of you as you draw this on your Satsuma. And as I say, just go around and try and preserve the main characteristics of the continents. Try and get them in the right place if you can, but don't worry about putting in too much detail. The key thing is that you can recognise them later on when we get to the next stage. So you should end up with something like this. I haven't done it absolutely perfectly. And then your next stage is to peel it, like I'm doing perhaps, and what I would say is try and get one consistent part. Yeah, and you can take the satsuma away like that, and then flatten it down on the table. You should have something that looks like this, if you can recognise it. Maybe, again, all one piece. Don't worry if it's gone into several pieces, you can sort of put those around if you like. Then get the pen, like I've got here, and just maybe if you want to use the map that I put up earlier and just sort of touch up the odd bit that has got rubbed off, perhaps, especially if the juice has come out of the satsuma. I should say feel free to eat the satsuma. There we are. So it should look something a little bit like that. Now you need your piece of paper, and after you've flattened out your satsuma in front of you, you want to draw everything that you see in front of you. So try and draw the edges of the peel like I've done here, and then also the continents, the lines, the outlines, the coastlines, make sure those are in as well, so that you end up with a picture in front of you which looks like the satsuma and the continents on it. And this is why it was important to touch up those bits of coastline that might have got rubbed off. It took a while. You can see I've got a cup of tea and a biscuit. It took ages to get this right. You'll be a lot quicker than me, I think. So have a look at this. See if you can recognise it. Okay, so what you might want to do now is just go back to the piece of paper that you had originally, or the map that you're looking at on the screen, and maybe compare the two and see what you think. Now obviously the key thing here to notice is that in that projection that you've created, you've had to tear one element from the other. So actually there are projections that do this, and these are called interrupted map projections. So you now have your new map projection. Obviously you didn't use mathematics to do it, so it won't be preserving angles, distances or area, but it does give you a new way perhaps of looking at the world. And sometimes that is all that is needed if we want to change someone's perspective. This is Stuart MacArthur's Universal Corrective Map of the World, which attempted to do exactly that, to put South at the top and Australia basically in the same position as Britain, and to therefore change the perspective of the people who were looking at this map. And we can take this a step further by forgetting about preserving distances or angles or areas, and instead base our world projection on where people are, so on the density of human population, which is exactly what this particular projection aims to achieve by Danny Dorling and Ben Hennig. What we need to remember is that there are distortions inherent to all map projections, and really it's a case of choosing the right projection for the right purpose of the map. And that might depend on the message that we're trying to get across, but certainly we want to be responsible and ensure that the map projection is as accurate and suitable as possible. Please remember to eat the satsumas and to clear up afterwards if necessary, and I hope you've enjoyed it. It'd be great to see some of the map projections you've been able to create. Bye bye for now.